Hello everyone, and welcome. Have you ever tried to solve a maze by starting at the finish and working your way back to the start? It's often much easier. In organic chemistry, we have a similar strategy for making complex molecules. It's called retrosynthesis, and today, we're going to break down exactly what it is and how it works. Simply put, retrosynthesis is a problem-solving technique where chemists plan a synthesis by working backward. Instead of starting with simple chemicals and randomly trying to build a complex target molecule, we start with the target itself and deconstruct it step by step. We constantly ask the question, what simpler, available molecule could I have made this from? This process helps us create a logical roadmap, avoiding dead ends and inefficient reactions. To do this, we use a few key concepts. First, we have the special retrosynthetic arrow, which looks like a double-lined arrow, equals. It's crucial to remember this arrow doesn't represent a real reaction, it's a thought process arrow that means is made from. The main action in retrosynthesis is called a disconnection, which is the imaginary process of breaking a bond to simplify the molecule. When we perform a disconnection, we generate idealized fragments called synthons. These synthons are conceptual pieces, often charged ions like a carbocation, positive, or a carbanion, negative, which may not be stable enough to exist on their own. Since we can't just grab a synthon from a bottle, we must identify their real-world counterparts, which we call synthetic equivalents. A synthetic equivalent is a stable, actual reagent that behaves chemically like our imaginary synthon. For instance, a very common synthetic equivalent for a carbanion synthon is a Grignard reagent. For example, if we want to make a specific alcohol, we can perform a disconnection on a carbon-carbon bond next to the alcohol group. This might give us a positive synthon and a negative synthon. We then identify their synthetic equivalents, which could be a ketone and a Grignard reagent. Suddenly, we have our plan. We now know we can make our target alcohol by reacting that specific ketone with that Grignard reagent. By working backward, we have discovered the forward reaction. Retrosynthesis is the chemist's version of strategic planning, allowing for the elegant and efficient creation of everything from life-saving medicines to advanced materials. Thank you so much for watching. If you found this explanation helpful, please give this video a thumbs up and consider subscribing to the channel for more chemistry tutorials. Don't forget to hit the notification bell so you won't miss our next video. Your support truly helps us keep making this content. See you next time.